well.
Come on, Joe. What's going on? Checking out the silage?
How old would you say I am? Don't answer that.
How would you? Yeah, don't answer that. Okay. All right. So, all right. This is the slide I got up. Is that what you got? All right. So, this is an environmental talk, or it's supposed to be. But to me, again, it's beef cattle production. But if we tell people, farmers, that, you know, come on out, we're going to talk about environmental stuff. Usually, they get these misconceptions in their head, and they go, "No, I'm not really interested in that talk. Someone's going to beat up on me, and I don't like regulators," and so on and so forth, right? This is the way I look at regulations, because I'm in engineering, okay, agriculture engineering. When I see regulations, basically what I think is it's a design problem. They're coming about because we've learned something new, and we've got to address a design problem, all right? So with that thought, let me walk you through this. What we had was, this past year, University of Kentucky did a program called Pasture to Plate, where basically they're trying to promote locally produced beef, you know, to local markets and stuff. And so they did this project where they raised beef cattle, heifers and steers at 3 different locations across the state, try to get them on the same diet, see how they do, measure their gains, back fat, loin eye, whole thing, right? Everything. And then talk to all these producers about these various stages of this project. Mine was the environmental. So they said, "Steve, we're going to put you on here for the environmental, but don't hamstring these producers with some, you know, crazy stuff that they got to do on their farm." I said, "Okay." So what I did was being in engineering, we've got calculators that'll calculate how much waste an animal produces. And I mean down to it. I mean exactly. The solids, the nitrogen, the phosphorus, potassium, all of it. How much moisture there is to it. We know what the nutrient value is because we got researchers that sample and weigh all this stuff and do all that stuff. And then we got calculators where basically I can plug in, and that's exactly what I did. We took those animals from 700 pounds up to 1,400, okay? So their average weight was around 1,000 pounds. We held them on the property for 200 days, finishing them out, okay? So I plugged that in. I plugged in 10 animals at 1,000 pounds, even though they're going to get up to 1,400, at 1,000 pounds for 200 days. And it spit out how much nitrogen, phosphorus, potassium, solids, all that kind of stuff that they were going to produce, okay? It came out to be 64 tons of waste. Does that blow your mind? It blows mine, okay? Next thing is I took the value of the nitrogen, phosphorus, and potassium, and I put a dollar value to it based on fertilizer prices past summer, okay? So that estimated value, that's what you're looking at. Estimated nitrogen, phosphorus, potassium, 158, 266, 188, 181, for a total of $600, okay? But that was estimated based on book values. Book farming, Charles. Thing is so the best way to do it is to actually take a sample of the manure, submit it to regulatory services or whoever, and get the analysis done on it, which is exactly what I did, okay? Which is actually, it should have come out to be like about an 888, 8 pounds of nitrogen, phosphorus, and potassium per ton. Well, on the second page, there's the analysis, okay? 18, 25, 34. Whole lot more, isn't it? I mean, 3 and 4 times as much. Why is that? Because we had those animals in confinement, we were finishing them out, so we fed them a concentrated diet. So therefore, the value of that manure was worth a whole lot more, okay? $2,100. How many critters would you have to sell right now to get $2,100? 2, okay? 2 large ones, yeah. Right? Yeah. So my point is, and that's off 10 animals. That's off 10 animals, okay? My point is that manure is worth quite a bit. I mean, almost as much as the animals in a way when you look at it. So it's on the farm. How can we utilize it to get the best bang for the buck? Where would you put it on your property? Where would it go? To utilize the nitrogen, phosphorus, and potassium, the organic matter. Where would you put it? Hay ground? Back on pastures? How about corn for silage? right? Okay, so I did the numbers on that too, because we know from book values how much nitrogen, phosphorus, and potassium is being removed by a crop, by the pastures, by the hay fields, by the corn crops. The thing with pastures, what you got to understand is when an animal's out there grazing, it's defecating and urinating in the field as it's eating. So the nutrient requirement for a pasture is about 1/3 as much as a hay field because they're adding to it, they're replenishing it. So if I took that manure from those 10 animals and applied it to some soils, well, that's the other thing is where you're going to put it. Okay, so all right, let me see if I got that one in there. So let's turn the page. All right, got to take my glasses off so I can read. This is the soil samples for this particular farm. Okay, see them? And what we're looking at is I mean, I don't care. Pick a field. All right. So the one I like to look at is for this one here is 305. 305 east hillside, which is this one right behind us. Okay. And there's the west. All right. So this is the west. 305 and west. All right. So anyway, you look at it, and so anything over 45 on phosphorus, you don't need to put that manure. Okay. To that ground, you're not going to get a phosphorus benefit. Does that ground need phosphorus? No. So if it doesn't need phosphorus, what you're going to do is you're going to add that manure based on the nitrogen removal rate, not the phosphorus. Because as phosphorus accumulates, that's a problem. All right. So if we apply based on nitrogen removal, I could take that 64 tons. I would need 162 acres of pasture to get rid of that manure for 10 animals. Does that make sense? You see how that math isn't adding up? I got 10 animals, yet I need 162 acres to get rid of the manure. Let's say I put it on hay ground, okay? I need I need 55. I need 55 acres of hay ground. Does that seem like a lot for 10 animals? I mean, you see how the scales aren't matching up? Or I could put it on corn ground, I need 17 acres. So my point is we're producing a whole lot more nutrients off these animals than what we can utilize on the farm, which is why we've got problems with the water supply in Flint, Michigan, in Toledo, Ohio, in Kentucky, and everywhere else. Okay? That's my point. Okay? So there's that. So then going back to that values of that manure, so I got that manure is worth $2,100. Well, we grazed, or we had these animals in 3 different locations. One of them was here, right behind you, okay? The other one, actually, no, it wasn't. Actually, they were in this area right in here, okay? All right, this earthen lot. At another farm I had, it was a similar barn to this one, okay? I'll show you a picture of that in a minute. And then the other place was basically Morgan County, and they had them on pastures. And they had a little shed, kind of like a lean-to they could go in and get out of the sun. So pastures versus that structure right there, and also on a dirt lot. Okay, so I put question marks on the value of that manure for outside grazing and dirt lot because why did I do that? Why did I do that? Why do you think I did that? How are we collecting this manure off a dirt lot? It's running off, isn't it? And on those pastures, like I said, if it doesn't need the fertility, then we're wasting those nutrients. Does that make sense? All right, so there's that. So now, this slide right here is the aerial photograph for a barn very similar to that one, but this was another one of those locations, okay? And again, this is the soil test phosphorus levels. Anything over 45, you're not going to get a yield benefit. What do you see? Those measurements were taken every 15 feet going away from that barn across that open concrete pad. So 742, 676, 749, 1032, 345. See what I mean? So what's going on there? So basically that rainfall is hitting that roof, it's rolling off, it's hitting that concrete pad, and it's pushing that manure down the hill. Okay? If there's a creek down at the bottom of this hill, which there is, that would kind of be a problem, wouldn't it? And I think back in the day, in the 60s, 50s, whatever, as far as barn designs, Charlie was asking for barn designs, we used to design barns along creeks so that when it rained, it hauled the manure away. That was our manure hauling. But now we got to shift. How can we make more money off that manure? So I looked at that and I was like, wow, what are we going to do, okay, with that fertility in that soils? Goes to the next slide. This one right here, okay? So look at this, and this is an actual NRCS collected this data. So I want to thank the NRCS for collecting this data for me. All right. What you're looking at is two different farms separated by that fence line running down that ridge. Okay. On the right-hand side is a guy that's been practicing rotational grazing, or water quality BMP, for 15 years. On the left is somebody else. Okay. So the NRCS sees this and they go, you know what? We need to do a rainfall infiltration test on these soils and see how long it takes a 1-inch rainfall event to percolate, to infiltrate these soils, okay? So they set up a column of water, they put in a 1-inch rainfall, event simulation, and it took 28 minutes or 12 minutes for that water to infiltrate into that soil. 12 minutes, okay? On the left-hand side, how long did it take?
As long, or it never did.
Or never did. Okay, so twice as long, that'd be about 24 minutes. Okay. What's that?
About run off.
It took 28 hours. And you're forcing it. You're forcing a 1-inch rainfall to go through there. So if you're forcing it, yeah, the infiltration rate on these hillsides, it's negligible. Okay? So again, water's transient. What we need to do is hang on to that water on our farms to take full advantage of it, right? Especially to get us through a drought. Okay, so I'll bring up that to basically to show you this little graphic right here. Okay, but what we did was on that farm, just like this field right behind us. You got a barn, open concrete lot, you got a hillside. Water infiltration on the hillside is negligible, but we want to hold on to that water. So what we did was we hooked up a tractor with a ripper, subsoiler, okay? And we ripped the soil based on the contours of that field, okay? Going down the hill, okay? Essentially matching up with that soil fertility that I showed you. And so what happens is when you run that ripper through there, it actually heaves up that soil and it creates a whole bunch of cracks and basically creates soil structure from where the cows and the activities basically compacted it. So now when the runoff comes off the barn, instead of flashing right down that hill, it's going to go down, it's going to hit that first ridge, it's going to go down there and it's going to percolate down through that way, then it's going to overflow, go down to the next one, go down through that one. We ripped it based on 5-foot centers. So basically we made one pass and then we just ran it back over on the tractor tire, overlapping one tractor tire. With me? And so I told the superintendent of the farm, this is what I want to do. I want to rip this every 5 feet going down that hill. He said, Steve, why do you want to do that? Why do we do that? It ain't going to last. Anytime I get questions like this, I go, okay, let's see what the literature says. What the research data says. Research data says if you rip that, you stay off of it with heavy equipment, it'll last for 10 years. 10 years. That means I'm going to take a benefit off that soluble nitrogen running down that hill. I'm going to take a benefit off that water for the next 10 years. At the end of the 10 years, if I'm still here, we're going to rip it again, right? And then the idea of what we did on this other farm, probably got a picture of that too. Yep, I do. What we did was we just fenced it off. We just fenced off that little area going down that hillside, went down 100 feet, and basically made a filter strip out of it. NRCS would call that a wastewater treatment strip, okay? And then on the gate, basically we fenced it off, but on the gate we hung 2 gates. One was a creep feeding gate, the other one was just a solid 14-footer. So the idea is we're going to allow those calves to go in there because we're going to interseed that hillside with orchard grass. They're going to go in there and they're going to get that orchard grass without mama being behind them. They're going to take advantage of it, and orchard grass removes a whole lot of nitrogen and phosphorus. Hopefully they're going to take some of that back out and defecate someplace else. If they can't manage it, we're going to open up the gate, we're going to let the mama cows in there. But we're not going to take it down to past, say, 6 inches. We're going to keep a nice, thick vegetative layer to basically work as a filter for filtering out those solids and those nutrients and hanging on to them. Okay? That's the idea. Again, it's trying to maximize some of that water, some of those nutrients before it leaves the farm so that we can get a yield benefit out of it and then turn that into a production benefit. And then, here's another one. So it goes to this one. This is going on cow comfort. So when I was on the farm doing all this work, and again, it had to do with this pasture to plate program because they had 10 heifers and steers, a blend. They had dairy influence, tall, lanky ones, you know, skinny ones. They had short, dumpy cattle. They had everything in between, mixed colors, males, females. Some of them they did implants on, some of them they didn't. So they're just looking at them. So one day the PhDs showed up to look at their animals. And I'm like, wow, nice to see you guys on the farm, you know. And so I walked into the barn. We were out on the concrete. And then we walked in, and right at the roof line on this other farm, right at the roof line, the concrete stopped and it went into this dirt floor bedding, okay? And so when I walked in, there was a step down, 6 inches, 8-inch step down. And it's the first time I'd been in the barn, I'm like, where's the bedding? How come there's no bedding in this barn? And one of the PhDs said, well, what do you want bedding for? You haul it in, you got to haul it out. And I thought, well, gosh, that doesn't make a whole lot of sense. So again, I go to the literature. What does the literature say? The literature shows basically a no bedding treatment versus a modest bedding treatment. First 2 columns. And it shows the number of heads the same, the initial weight's the same, the final weight, a little bit of a difference. The tag score. What's the tag score? How many hanging tags those animals have? When you take an animal to stockyards with hanging tags, do you make more money or less? You make less. Okay? Average daily gain. Oh my gosh. Higher average daily gain by using bedding. Carcass weight. Higher on the carcass weight. Dressing percentage. Oh my God. Here's percent choice. Do we care what these animals taste like when they leave the farm? I do. I mean, a lot of people are just interested in average daily gains, but seeing as how I'm kind of particular about how my cattle are raised, I want to know that they were raised correctly, and that also affects the marbling. So it's going to taste better, okay? Bottom line is the increases in heads, or your profits, outweigh the cost of bedding 3 to 1. Need I say more?
You got a cost here what it costs to take the bedding out?
Nope.
That's the problem.
That's the problem. Could be.
That's the problem.
Yep.
Because you got $81 profit, but by the time you figure your labor and your expense of carrying the bedding out, which is, you got to figure what is it, one round bale of straw per head per year.
That's one way of looking at it.
Well, I got a simple mind.
That's true. Here's another one for you.
Yeah.
The PhDs, when I said, why are you guys on my farm? What are y'all doing here? What'd they say? Well, we had to come check this, our best growing steer on the study. We had to come see him because he's got foot rot. Well, where'd the foot rot come from? Maybe from not having bedding? Maybe from stepping on that concrete edge between the concrete interface and the dirt floor? Maybe from being on that wet slop in that barn because it wasn't bedded down? And then could you not take that bedding out and apply it where it needs to be, or needs to go from a nutritional basis for agronomic rates, but also take advantage of that organic matter that you brought onto the farm as well, into that bedding? You with me? So, but it's a good point on the labor.
Yeah.
But we need to clean the barn out anyway, but we'd have to clean it out more often and haul out a whole lot more. But again, that manure was worth a whole lot of money.
Yeah.
So there's that.
The biggest difference in that to me, of course, outside the box. Now I'm thinking quality. I'm looking at that percent choice.
Yes.
I'm looking at that percent choice. I wouldn't have thought that.
Yeah. Isn't that something? Again, it's looking at a picture and seeing something different than what everybody else sees. You know, and it's actually going and looking at some actual data to see what this actually says. Because, like,
You know, we in other words, where I'm going to, we tend to go toward the genetics on that, which is there.
Yeah.
But still, if this is, you know, a test.
yeah. And on the
that-
genetics,
yeah,
do we natural breed or we AI?
I do both.
Do both?
I do both.
But as far as changing herd genetics, you can make some huge, profound changes with AI in a short amount of time compared to natural. As far as if you were interested in changing loin eye dimensions and back fat, and so on and so forth.
Yeah.
So, but AI is kind of a pain, isn't it? But again, it's just like the bedding. It's kind of a pain. But you can reap some benefits off of it, right? All right, so I got this other slide right here. Again, you take a grazing class, they're going to show you a graph similar to this. Normally they show you a smooth line, right? You know, nice little double camel hump line showing the growth curve for tall fescue. They'll show you this and they'll go, yeah, you can fill in that trough for July through September by growing some warm season grasses. You might be able to help yourself out from say December to January by doing some stockpiling if we get the rain, if we don't have a frost, right? If your stocking density isn't too high, you can stockpile some pastures, right? I look at this and I go, what's a farmer do during the troughs? What do we do during those summer droughts? Because the guys' farms I go to, they don't have warm season grasses. I mean, it's just all fescue. And then stockpiling, I mean, yeah, that's great if you can do it, if your stocking density isn't that high. But I'm like, what do you do during those troughs? So that to me, I fill in these troughs by giving basically an animal another place to go, okay? So if you're doing rotational grazing, which is what we recommend, ideally you would have 6 to 8 pastures, okay? So let's say 8. What I want to provide is I want producers to think about, I need a 9th pasture. I need a 9th field. And that field is a barn, it's got a roof on it, it's covered. They can go in there and they're not going to be tearing up my ground in the wintertime. They're not going to be, you know, when we hit that drought in the summer, I'm not going to open up all my gates and let them go wherever they want so they can get a mouthful of feed. I'm going to put them in a barn and I'm going to cut and carry. I'm going to haul hay to them. I'm going to get them in that barn and I'm going to clean up that manure and I'm going to put it where it needs to go. It's that simple. I got stormwater diversion on another farm. We got a barn exactly like that. We're harvesting the water off that barn and we're watering livestock with it. We're cutting down on the water bill for that farm by giving them free water. And that's an immediate benefit for that farmer because that's what farmers want. I want to do something simple. I want to see a benefit within 1 year. Okay? How are we going to do that? And they also got a short-term memory. Winter's nasty, winter feeding's nasty, but after they get out of it, they won't think about it again until next year, right? So a barn to me is a long-term prospect, which goes basically to this last slide. That's basically one of the designs that we're talking with the NRCS as far as cost sharing for, because barns are expensive, okay? I got an idea of what a farmer will pay per head for a barn, and it's not enough to cover the cost of this. So we have to have cost share to address this because, again, farmers don't have the money. We put them in. We're addressing natural resource concerns. We're doing the right thing. It's going to be better for animal production. We're going to be able to feed the masses that we're going to have, the increase in population with limited land usage. We're going to be able to do it if we start thinking out of the box. And this would be better for the environment, better for water quality, and I think better for animal welfare as well, to a point.
What's your cost? What's your cost on a barn like this on your design? What's your thoughts on it?
Around $14 a square foot, which is about 3 times more than what a farmer will pay. So I can get a third out of him. What I need is the NRCS or the taxpayers to pony up on the other 2/3. And then we can have better nutrient management. And this is done basically in the dairy industry. Confinement's done in hogs, it's done in chickens. There it is. But basically on the beef cattle side, you've got to do a learning curve because dairy producers know more about the bedding, know a little bit more about the confinement than beef. So we got to kind of walk into it kind of slowly. But we also have to have a structure that can't be abused like we had before with the cost share.
Basketball court?
What's that?
The basketball court?
The basketball court. I got to refinish that tractor, you know.
All your nature lover people, they want to turn chickens and the hogs back out.
That's true. That's an animal welfare thing. But see, if you do that, because I remember we pastured hogs,
Yeah.
okay? And there was never an odor problem from pasturing hogs. Now, yes, if you weren't paying attention, you could lose the back tire tractor in one of those watering holes that they made. And yeah, I don't know, farrowing in those little Quonset huts we had, there were some issues, but you didn't have that problem. But shifting into confinement, yeah, it made things a whole lot easier. We could farm with less people, made it a whole lot more efficient, cut down some mortalities. But yeah, those animals don't know, they don't get that opportunity to be natural. But if I built a compost bedded pack barn, okay, where you're supposed to till it up and they sleep and work out on that bedding, and I put hogs in it, it'd be in hog heaven, okay? I wouldn't need to have a tiller to go through that barn and till up that compost. They'd be rutting it up for me, you know? Wouldn't have to put on no nose rings, and it'd be done. I mean, it's just ways of doing things. I got another buddy of mine. He does cattle and he does chickens. He does chickens outside. He runs these tractors and stuff. He can run more animals per unit area than if he just ran just cattle. He gets more meat off of it by doing this variable thing that he does with chickens and heirloom turkeys and beef cattle. More production per unit area than if we just had straight cattle out there.
What size building would you need for 40 head?
40 head. What I'm trying to use is the old standard NRCS drawings from back in the day, which is a 40-foot wide structure, 40 head of feeders or 40 head of cattle. Or
40 head of cattle.
I do it 40 by 80. That's 2 linear foot per head. And the bedding behind there is enough room for them to have about 55 square foot per animal. If you had about a 12-foot drover's lane running down through the center, or off to the edge of it. So there you go.
Now here today, Steve, get back to the real problem you got today. Cows up there, a little muddy. They had to walk all the way the water down here, clear up the hillside, caves over there, and the water hole. Why would you not put a creep gate on that field out there and let the caves, the small caves, go into that center field all across there from both sides? Let them figure out how to get back to mom at night.
They could.
Would they damage that enough that you would not want that on that grass?
Probably not. The thing is, back in the day, at the top of that head cut right there, you can almost see right up above it. That's where they used to roll bale feed. You can kind of see the remnants of it right now. See it?
Yeah.
And I'm like, why are you roll bale feeding right there at the top of that watershed when you got that flat area up over there on the other side? Why would you do that? And they go, Steve, shoot, man, we never thought about it until you just asked. But yeah, it makes all the sense in the world. Yeah, we'll stop doing that. But the head cut's already started, and now I got to fix the head cut.
But you wouldn't have a problem letting the calves in a
No.
flock from 2 different herds like that.
No.
Absolutely not, because I mean, it looks to me like you get them out of the mud.
Yeah.
You're using what you got.
Yeah. I mean, only the cows would get upset because they'd be looking for the calves, but the calves wouldn't care at all. And they would come back.
They come back.
They would.
So you could pretty much use it year-round grazing if you had enough cows and calves. Let the calves in there year-round.
Problem is like, you know, this isn't my farm, but I give them input on what to do. But yeah, there's a lot of good ideas to do out there.
I'd open my gate and let them go in the orchard too.
Yeah, well, there you go. You can put the chickens out there. You put the chickens in that orchard, they take care of every bug and insect in there, and then you wouldn't have to do spraying. How was this for a tour? Is it good?